Swayam Prabha. Digital India. Educated India.
Hello student. So today we will start the model 8 chemical transformation. Previous few lectures, 3 lectures on physical transformation, where we had discussed about the unit operations and recyclings. Now the same transformation will continue as in chemical transformation, where we will talk about very important issue about whether waste could be used as an fuel. Then we will talk about the incineration process, types of incineration process. This course is specially designed for the environmental engineering students, whether it is from graduate or postgraduate students. So, in this one we need to discuss about the gases produced during the incineration process or combustion process, that we called as in fuel gases, and also the solid residue which remained after the combustion process or incineration process, that we will talk about in this particular model. Okay. So, first we will start with the same functional element. Now, the previous module was on the processing. Now, we will talk about transformation, which will start the chemical transformation. And now, this lecture can waste could be used as an fuel, that we will discuss today. So, the first need to be understand that primary difference between waste incineration or other combustion system, that the incineration process treat incoming waste with great variation. So, normally in combustion process, whatever the fuel or any kind of material we are using, that is a homogeneous kind of material. But here in the incineration process, the heterogeneous kind of material will come up under the combustion process. So, you can see here the different variation of the waste will come up into the incineration process. So, practical design limit allowable variation of the waste composition. So, that was I was talking about various kind of waste, and different waste composition also could be used into the incineration process. So, this is one based on the manual of MSW in 2016, which was modified. It was given based on the few parameter. We can see that whether the waste could be incinerated or could be possible to produce energy from the waste. So, here the moisture content should be less than 45%. The organic matter which is required for the combustion process or incineration process, that is more than 40% should be there. The fixed carbon, this is one of the very important parameter which we have discussed in the one of the lecture also, where we talk about the characteristic of the waste. If fixed carbon is very high, then there is no need of combustion process, because it is unnecessary, lot of energy will be required for the combustion process. A total inert also should be less than 35%. Why? Because in India, if you see the characteristic, a lot of inert content will come up into the waste, final waste, and especially the calorific value. This is one of the important parameters, should be more than 1500 kilocalorie per kg, and this calorific value could be possible only and when the dry amount, especially the paper percentage, plastic contents, or whatever is the combustible material, the percentage is very high, then only we can get this kind of calorific value. And if you know that in India, because India or developed country is known for production of more biological waste. If biological content is more than 60%, 70%, so it is very difficult to get this kind of calorific value. Now, the basic consideration before the design, what parameter also I show it, but the another considerations like best available data on the amount and composition of each waste type. That was I was talking about. You need to know that the best available data should be available to see that whether how the compositions are changing with the time, and even future waste generation, and in future how these compositions are going to change. That kind of data should be available, and the effect of future change, that is what the future changes also need to be known, because the same incineration process or combustion process will work for another 20 years. So, obviously, your commercial facilities or industrial development will change. So, obviously, the waste composition will also change. So, that effect also need to be understand and need to be considered. So, waste lead to incineration plant consist of domestic, commercial, institutional, industrial waste with great variation. So, here you can see that the recent waste generation data shows presence of huge quantity of packaging material. I think we talked in many lectures. So, huge amount of packaging material also is producing in India. So, and another the special kind of waste like street sweeping waste, that is the inert content, construction demolition waste, that is huge amount is getting produced in India, is not suitable for the incineration process, because this contain uncombustible matter. Okay. So, you can see here domestic demolition waste and specially the street sweeping waste is not feasible for the combustion process. So, here again the very important issue, see, if you are planning for incineration process, you need to know these kind of very important considerations, because when you collect the mixed waste, when you say the dry waste will go to the incineration facility, all kind of dry waste should not go to the incineration plant, because this street sweeping also waste is very huge amount is getting produced, that should not be reached to the incineration plant. And also that same dry waste also again has to be segregated, like metal, glass are not combustible. So, that also has to be segregated before the waste is going for the incineration process. Now, the key parameters. So, there are three major parameters need to be characterized or need to be considered before going for the incineration process. First is the heating value. So, it is the heat generation per unit or volume of combustible material completely burned, that heating value has to be known, that we called as an calorific value need to be known. And heating value is again is a proportional to the waste that is combustible. Okay. More combustible percentage will be there, obviously you will get the large value of heating value or calorific value. Now, next parameter is the moisture content. So, the critical determination is very important of the moisture content. If more moisture content is there, obviously that kind of waste will be required more energy for the combustion. So, what could possible that? So, when you put it the waste having more moisture content, so initially the waste will get dry. So, unnecessary lot of energy will be required for the just to dry the waste, and suppose the waste consists of 70 to 80% of moisture content, means only the remaining volume will be only 20%. So, there is no benefit of combustion also, and also to produce or to get energy recovery from such kind of material. So, it is generally found to be high in waste containing the high proportion of food waste. This is what the problem in developing countries. More amount of food waste will have more amount of moisture content, and if it is not getting segregated. Next point is the ash content. This is also we have seen in the characteristic slide. This is analyzed as 550 degree centigrade, because in the incineration process also temperature goes to more than 1000 degree centigrade. So, need to know that how much is the ash is getting produced. If more ash productions are there, so obviously again the disposal of this ash is also another major issue could be. So, that also need to be, this is also very important parameter to consider. Now, the waste characteristic, to see that waste as an fuel, it need to be determined moisture content, that W, and in another one of the class I have explained about how to measure the moisture content, the ash content, combustible solid or we can say volatile solid, and based on these three parameter, moisture content, ash content and combustible solids or volatile solids, will prepare Tanner diagram to examine if the waste can be combusted without auxiliary fuel, or waste can be incinerated or combusted without adding of any extra fuel or extra combustible matter with the waste. So, this is the Tanner diagram you see here. So, this is the ash percentage, this is moisture content and this is combustible percentage. And see here, this is the boundary, like W moisture content, if less than 50%, ash content less than 60% and combustible percent more than 25%. So, you will get this particular area. So, and this area is known for, this is feasible for the incineration process. So, if your waste characteristics is under this particular area, means waste is able to or feasible for the incineration process. So, I will show some of the very basic slides. Suppose some data is given, so how to prepare the Tanner diagram, and based on Tanner diagram how we can see that whether the particular kind of waste required auxiliary fuel or it will not be a feasible for the incineration process. So, how to read a Tanner diagram? So, consider this is one point is given in the Tanner diagram. So, how to read that? To based on that whether we can know that how much is the moisture content or ash content or combustible percentage. So, first to find the W, draw a line like this and given point parallel to the percentage combustible to intersect the W side of triangle. So, this will be the W value, moisture content is 40%. Now, similar way to find A, draw a line like in the same way and see here, like this is parallel to the these lines and you can find the ash content that is 25%. Similar way combustible percentage. So, for combustible percent we can parallel line we can draw like this and you can find the combustible percentage, that is 35% are coming. Okay. By that way we can understand, we can read the Tanner diagram. Suppose some data is given. So, what will be the moisture content, ash content or combustible percent of that particular waste characteristics. So, now how to plot a Tanner diagram? So, suppose now these values are given, moisture content W is given 15%, ash content A 35% and C, that is combustible percentage 50% is given. So, now how to plot that particular waste characteristic into the Tanner diagram. So, begin with plotting of 15% W on the percentage moisture side. So, moisture side. So, now 15% we put it, this is the 15% moisture content. So, we put a line and to draw a parallel line to percentage combustible side. Now, next plot 35% A. So, 35% A, this is the 35% A and draw a parallel line onto the moisture side. And now, for C combustible percent 50%. So, this is the 50% and draw a parallel line to the ash side. Now, we will get one particular point. The intersection point of the above three lines will give a point considered to the given value of W, A and C. So, here the value of that particular base characteristics we got it. Okay. Based on that, we will go for one problem also, and then we can see. The problem statement is that a study from China and Philippines is given below. The base characteristics are given, like for China, Guangzhou, China, the mean values are combustible percent, ash content, moisture and calorific value is given, and similarly Manila of Philippines, some values are given. So, now we will plot based on the Tanner diagram, and we need to know that the problem statement is that which country will require auxiliary fuel for combusting their waste. So, based on that Tanner diagram, we can know that whether the waste will be required auxiliary fuel or not. So, now this is the Guangzhou, China characteristic, and this is Manila characteristics. So, now we will put first the Guangzhou one. So, the Guangzhou, China is coming like this, and Manila, Philippines is inside the this particular area. So, means the answer is that the Manila, because it is feasible for the incineration process. So, do not require auxiliary fuel, but the China waste is out of that particular boundary. So, means it is having a low percentage of combustible matter. You see here, if you plot like this, so it is having only 25% of combustible matter. So, obviously, it will be required extra auxiliary fuel for the combustion process. So, now once we know that three major parameters like moisture content, combustible percentage and ash content, now the heating value or calorific value, what exactly is the heating value and how to measure that. So, some variables are used for determining whether a waste can sustain the combustion process without supplementary fuel or auxiliary fuel, such as the lower heating value, that is one parameter. Based on that, we can know that apart from the moisture, ash and combustible percent. So, is the lower heating value is the energy released upon complete combustion of a fuel. So, when the complete combustion of fuel, carbon to carbon dioxide, hydrogen to H2O, sulfur to SO2 and water is evaporated, leaving the process in its evaporated state. So, understand that the lower heating value is calculate the complete combustion, where water is evaporated, leaving the process in its evaporated state. Similar way, other parameter called higher heating value, H high, that is energy released at complete oxidation and water leaves in the combustion process in its liquid state. Okay. That is the only difference between lower heating value and higher heating value, and it expresses the theoretical maximum energy released from the fuel. So, any equipments like a bomb calorimeter is there, from that we can analyze the calorific value or heating value. There we will get the higher heating value data. Okay. And finally, we will calculate based on the higher heating value, we can calculate the low heating value parameter. The difference between H low and H high is the heat of condensation of the water vapor contained in the flue gas originating from the moisture in the waste and moisture generated by the oxidation of the hydrogen bound within the chemical structure of the waste. Okay. Now, H high can be expressed as H high is equal to H low plus W plus H into 8.937 into 24.45 kilojoule per kg, okay, where W is the moisture content, H is the hydrogen percentage. Okay. And H low is calculated from the elemental composition like CHONS and expressed using the empirical formula like H low calculate by 348 C percentage plus 939 H percentage plus 105 S percentage plus 633 N percentage minus 108 O percentage and 24.5 H2O percentage. Okay. So, this is the percentage of carbon, hydrogen, sulfur, nitrogen, oxygen, and this is water. And the term calorific value is often used instead of heating value. In especially in India, we never talked about the heating value. So, this net or inferior may be used for low heating value. So, in India we called gross calorific value and net calorific value. So, lower heating value in India we called as a net calorific value, and higher heating value in India we called gross calorific value, GCV and NCV. Okay. So, just again I am repeating that in India we called higher heating value as gross calorific value, and lower heating value we called as a net calorific value. So, this one numerical will solved where considered 1 kg of waste with the following chemical compositions are given, like carbon 30%, hydrogen 4.3. Likewise, the percentage is given. Now, the question is that the problem statement is estimate the lower and higher heating value. So, first we will calculate the lower heating value by this equation, and we will get 11.48 megajoule per kg, and higher heating value by this particular equation we can calculate, and we will get higher heating value 12.9 megajoule per kg. So, once the characteristics are given like CHONS percentage and H2O percentage will be given, we can easily calculate the theoretically net calorific value and gross calorific value. Based on that gross calorific value we can calculate. Now, this I think we are already talking about waste as an fuel. So, also we have to talk about RDF. This is a very important word, especially in India. Last 20 years, 30 years we are using that. India had come up with RDF plants, and recently under Swachh Bharat mission also number of RDF plants has been trying to install. Some plants are already started working, and some plants will come up again. So, we will understand here the what do you mean by refuse derived fuel. So, it is defined as fuel derived from the combustible waste fraction of solid waste. This is refuse derived fuel means fuel derived from the combustible waste fraction of the solid waste, and these combustible fraction could be plastic, wood, even the organic waste also, if the waste do not have more moisture content. These kind of waste in the form of pellet produced by drying, shredding and compaction of solid waste. This is based on the SWM rule 2016. Then again composition of RDF has a higher concentration of combustible material than those in the parent mix MSW. So, if suppose mix MSW means obviously we are saying as a dry MSW, but is a mix, but in RDF we need higher concentration of combustible material. So, quantity of RDF produced per ton of MSW varies depend on the type of collection, pre-processing and composition of solid waste source. So, obviously is again depend upon the how best we are able to collect the waste, and how best we can pre-process the waste for the RDF process. So, quantity of RDF depends on the characteristic of incoming waste feed, segregation into combustible and non-combustible as an prerequisite. This is need to be understand. The segregation into combustible and non-combustible is a prerequisite. So, this is what based on the Municipal Solid Waste Management Manual 2016. I think here one hierarchy is given and waste to energy is come. I think just last unit, once you do the recycling, composting or biological treatment, then the remaining waste should go for waste to energy before landfilling. Now, utilization of refuse derived fuel. So, you can see here net calorific value of refuse derived fuel versus coal. So, you can say the Indian coal is having net calorific value is 2500 to 5000 kilocalorie per kg, okay, in 1 kg, and mixed plastic is very high 6000, but the problem is more flue gas will produce, polluted gas will produce. But important in India that segregated municipal solid waste like plastic, cloth, jute, paper or multi-layered polythene, these are thermocol, coconut shells, these kind of segregated means MSW will have the 2000 to 2500 kilocalorie per kg calorific value, means industry required high calorific value such as iron and steel like 9000 kilocalorie per kg, that kind of calorific value required in such kind of industry like iron industry and steel industry. Using waste as a fuel become impractical, because obviously they will be required that kind of material which will get more calorific value is around 9000 kilocalorie per kg. But however, the industry such as cement required low calorific value of waste around 3000 kilocalorie per kg. So, obviously, if these kind of mixed or segregated MSW can be used for such kind of industries. So, fuel having calorific value of around 3000 kilocalorie per kg can generate enough thermal energy required in the processes in these plants like cement kind of industry, reducing the use of non-renewable fossil fuel like coal. So, using waste as a fuel in such industries could be economically beneficial. So, is not that ki entire these kind of waste will put it into the cement industry, maybe 5%, 10% can be added into the as an fuel for this kind of industry. So, I come up with two case studies. One was Ghazipur landfill in Delhi. You can see here, this is the Ghazipur landfill. So, of the 2000 tons per day of waste received at this landfill, the facility initially started to process 1300 tons per day to generate 433 tons per day of RDF. So, out of 1300 tons per day will generate 433 tons per day of RDF, which will utilize for the generation of 12 megawatt power. That was the idea. And this project started under PPP program, public private partnership, operates is infrastructure leasing and financial services. This is one company, the private company which was working with local corporation ILFS. So, this was the waste to energy plant in Ghazipur. It provides a scientific solution to address some of the environmental health and safety hazard possessed by 29 hectare dumping ground containing 12 million tons of accumulated garbage. Okay. But I think lot of issues has come up in the Ghazipur landfill also, because you see here the very big stack where flue gases used to come out from this combustion process or incineration process. The plant in India, first waste to energy plant compliant with aero norms for emission along with the highest standard of pollution control measure. The plant has a 7-stage pre-processing section converting waste to RDF of high calorific value. So, 7-stage pre-processing stations. To implement the highest level of transparency, a continuous emission monitor system enable online viewing of key emission parameter on real time basis. That was the one very important issue under the incineration. We will talk in the one special lecture I put it for the emissions from the such kind of incineration plants or RDF plants. So, this was the online measurement emission monitoring, and project aim for generation of employment, alternate livelihood or fractional literacy, creating societal benefit. The idea was that because the segregation of pre-processing was very important. So, local rack pickers, how best they can get the some kind of employment working in such kind of plants, that was also another benefit they found. This is one of the another photograph. The project also helped to serving 260 hectare of scarce urban land valued at over rupees 2000 crores, because lot of area, and you see here nearby residential area is also there. So, obviously, and I personally believe that incineration process is one of the very important process to treat the solid waste, because it will reduce 90 to 95% of volume. And in last lectures where characteristics, or when you talked about weight and volume, so this volume is very important, because the entire or most of the waste is going to the landfill area, and the what is important now, how best we are able to reduce the volume of waste, and incineration or combustion process is the best process where 90 to 95% of volume could be reduced. But the problem along with that incineration process will get large amount of ash that will get produced in the combustion process. Also huge amount of flue gas will produce, that is highly polluted gas, and that kind of treatment facility is required. Treatment will be required later on, but first need to understand the emissions, what kind of characteristics will come up. Based on that we need to install the proper treatment facilities. That is what I think we are going to talk into the few next lectures. This is another case of Hyderabad, is recently started. It is a 11 megawatt power plant utilizing 1100 tons per day of MSW. This is being installed in the Nalgonda district of Telangana by RDF Power Project Limited. This is what you can see, that RDF Power Project Limited. This was the subsidiary of same company, that ILFS. The plant will produce refuse derived fuel for in-house incineration and power generation. That was the idea behind this plant. So, here we will finish this lecture. Now, we understand that waste can be used for the fuel. Both way we can understand, like one, the volume, how best we can reduce the volume, then we can go for incineration if we are getting the proper characteristics of that particular material. And also while combustion or while incineration, if you are able to produce some kind of energy, then always is a beneficial, because the operation cost is very high of the incineration plants. And suppose the local authority or even under the PPP project is not able to run the incineration plant, there are number of industries which required energy or which required lot of fuel, and most of the industries they are using coal as an fuel, and coal is very costly for such industries. They are already looking for alternate of coal, and these kind of material, if you are not able to run the incineration facility from the local authorities, or the quantity is not that large to install the incineration facility, we always look on to the RDF kind of facility, where the entire material is getting segregated, and this segregated material will have large amount of calorific value, and more percentage will be the combustible fraction that we can properly transport to the such particular industries, and these industries can use for the their combustion process. So, recently I think 2 years before, I came to know that Meghalaya is one of the northeast state. They made it as a particular rule, their pollution control board, because the Meghalaya have a number of cement industries. And what rule they made it that the each cement industry need to be use minimum of or 5% of plastic waste for in their cement industry for the combustion process. So, that was one of the very important news, and I also showed it that cement industry which required 2500 to 3000 kilocalorie waste or fuel. So, the MSW, if it is segregated, and especially the plastic which is having very high calorific value, that can be used for the such kind of industries. But also because I am also environmental engineer. So, always I am looking onto the two major pollution from the incineration process. One is flue gas, how best we will be able to treat that, and how best we can dispose the solid residues produced from the combustion process, that has to be looked upon. So, the next lecture we will talk about first, I will talk about incineration process, followed by the environmental treatment. Okay, thank you.